Hi, I'm an old guy and I do maths, and our task today is to draw the graphs of x to the power of negative 2 and x to the power of negative 4, y equals x to the negative 2, x to the negative 4, and to find out where they intersect. So the reason we're looking at this is because a student of mine saw these and asked about them. So let's just get into this and see what we can do. Now, I think that the key to understanding this and making this very easy is to think about what these actually mean. And I'm just going to write in the left-hand corner here, x to the negative 2 equals 1 over x squared. And immediately we can see that what we're looking at is we're looking at a truncus. And x to the negative 4 is equal to 1 over x to the 4. So there are a couple of things to observe here. First of all, we've got a truncus, so let's just draw that. Now that looks very roughly like that. Badly drawn, I apologize, but it should be straighter here. It's got an asymptote at 0 for both x and y axes. If we put 0 into this, 1 over 0 squared, that's just going to give us nonsense. So x can't equal 0, so therefore the y-axis, which is this, is an asymptote. And as for the x-axis, how on earth do you make that equal 0? Just try. So both the x and y axes are asymptotes. This is the interesting one. Now, those of you who have seen this before won't be surprised. But what we're looking at here is we're looking at graphs of even powers in this form. And so what happens is the shape remains basically the same for this, and indeed 1 over x to the 6, with a couple of little, I suppose we could call them wrinkles to consider. So I'm going to draw this, and what you're going to see is that it does the following. So I hope that this is clear enough with the red ink. And again, it's poorly drawn, but because I know the answer, I can confidently say that we have 2 points of intersection, and this is y equals 1 over x to the 4, and over here, just so that there's no confusion, y equals 1 over x squared. Now again, as I say, you should be familiar with 1 over x squared. If you've got to this point, you should be familiar with it. 1 over x to the 4, as you can see, has a similar shape with a couple of differences. It's closer to the x-axis down here, and it's slightly further away from the y-axis up here. And we can have a quick look at why that might be the case. So let's just take a number. Let's take the number 3. And if we put that into 1 over x to the 4, what we get is 1 over 3 to the power of 4, which equals 1 over 81. If we put that same number into 1 over x squared, what we get is 1 over 3 squared, which equals 1 over 9. Now that explains why, and this is, as I say, poorly drawn, but it explains why 1 over x squared is in this position and 1 over x to the 4 is in this position here. This is much closer to the x-axis. Now, once we get up here, the opposite occurs. So if we take, let's just take a very simple number, 0.5, so a half. So that is 1 over 2 to the power of 4. Now, 1 over 2 to the power of 4 is 2, 4, 8, 16. 1 over 16, which we've got 1 divided by 1/16, which is equal to 16. So if this point here, say, were a half, this value would be 16. Now, what is this? What is the equivalent of this when we put it into 1 over x squared? Well, we get 1 over 2 squared, which is 1 over 1/4, which equals 4. So it's much closer to the x-axis in this case, and therefore a consequence of that is that it tends to hug the y-axis a little bit more. So that explains the positions of these things. Now, that's a lot of talking before we get to this point here. The question is, what are these points of intersection? So let's go to work on that, because again, the algebra of that seemed somewhat confusing, but instinctively I think it's possible to work out what the answer might be. And of course, if we consider this in terms of an algebraic expression, this point and this point must be where this equals this. So we can write that in another way. We can write it like that. And we can set about solving that, which we will do in a minute. I just want to say something though. It should appear fairly obvious that there's only one number, positive or negative, that will work here, and that's 1. 1 over 1 squared is 1. 1 over x to the 1 over 1 to the power of 4 is 1. 1 over negative 1 squared is 1. 1 over negative 1 to the power of 4 is 1. Now that's all very instinctive, and it's the sort of thing that if your maths teacher is looking over your shoulder when you name these points and says to you, well, how did you get that? And you go, well, I just know. That's not going to work. So here is the working for it. So we have this. Now, what I would do here is I would multiply everything through by x to the power of 4. So we'll just do that. So times x to the power of 4. And what we get is we get 1 minus x squared equals 0. Now we can do something with that. So a little bit of rearranging. I'll go through this in detail. So x squared equals 1. So 1 minus x squared equals 0. Negative x squared equals negative 1. I've moved the 1 over there. I've multiplied through by negative 1 to get rid of the negatives because I don't like them. And what I'm going to do now is I'm going to take the square root of each side, and what I'm going to get is the following. X is equal to plus or minus the square root of 1. Well, the square root of 1 is 1. So we can have, it's also negative 1, x equals 1, which will be this point here, or x equals negative 1, which will be that point there. Now let's just get all of that in focus for you. So if we put -1 into both of these equations, we get the same value. If we put 1 into both of these equations, we get the same value. And that is the working for it. So that is how you draw the graphs of x to the power of -2 and x to the power of -4. The breakthrough realization here is that this is what they are. Once you see this, some bells should ring in your head. Over here is simply an explanation of why the paths of these diverge. And the second part of this question is answered down here simply by equating these and solving for x, and that's how that is done. Okay, well, thank you very much for watching. I hope you found that useful. If you did, please like and subscribe, and I'll see you next time. Bye.